This meeting is being recorded.
The next section of the Chapter 15 Chemical Equilibrium worksheet introduces what's called the reaction quotient. This is designated as Q, as noted here. And this gives you the same ratio as would an equilibrium expression, but for a system that's not at equilibrium. So this is why it's called the reaction quotient Q versus K. So to calculate Q, we would just substitute in initial concentrations of reactants and products into our expression the same way we would an equilibrium expression. So let's take a look here. If we have a Q that equals K, the system is at equilibrium. If K is less than Q, that would tell us that there's too much product, and then our equilibrium would shift to the left. So we can draw like a little arrow here pointing to the left from that K is less than Q. And then here, when K is greater than Q, that would tell us that our reaction would need to shift to the right to reestablish equilibrium. So remember, our systems will always be striving to reach equilibrium. So let's take a look at sample exercise 13 here. And we're given some information that at 448 degrees Celsius, our Kc value for this reaction right here is 50.5. We're going to predict in which direction the reaction would have to go. Would it shift left or shift right? Which way would it proceed to reach equilibrium if we're given some initial concentrations of our reactants here and our product? And we're given that in a 2-liter container. So we need to take that into consideration when we're plugging in concentrations. So let's write our equilibrium expression over here for this reaction. We know that that's going to be the concentration of HI squared over the concentration of our reactants, H2 and I2, at equilibrium. So if we're comparing this to non-equilibrium conditions, remember 2.0 moles of our product in a 2-liter container would actually be 1.0 times 10 to the negative 2 moles per liter. When we plug that in, we're going to square that value from our stoichiometric coefficient 2 here in the balanced equation. And then on the bottom, we're going to plug in our reactant. So we have 1.0. So we can, instead of writing this 1.0 to the negative 2, we can divide that, right, and just say 0.5 times 10 to the negative 2. And then we can also plug in, instead of 3, divide that by 2, we get 1.5 times 10 to the negative 2 molar. So now these are all concentrations. We know that the units will cancel, so we end up with a Q approximately 1.3. So now let's relate our K and our Q. If you write them alphabetically, like so, and then we put the values here. So 50.5, this is 1.3, and I say that K is greater than Q. I can turn that into an arrow. And remember that my equilibrium would need to, or reaction rather, would need to shift towards the right, towards products, to reestablish equilibrium.